Hey guys, Mrs. Stans here. So we're on lesson 10. You can see what the objective is if you can just write it down on the lines. And you can start your do now. I, of course, will go over it in this video. Next time I see you, I will answer any questions you had from lesson 9. And we're going to do some stuff together in this video. And the rest you have to finish on your own. Your homework is to finish the lesson. So let's get started. So remember, you do have a copy of this. You can watch it on your own time. If during class here you seem to miss something, you do have a test coming up, so it's very important that you do pay attention and you do your best to understand and finish this lesson on your own. And when I see you, I'll answer some questions. So this was a Regents exam question one year. Write an equation that defines m of x as a trinomial where m of x equals that. Really, all they're asking us to do is to simplify this side of the equation. So a binomial times a binomial, we have a lot of distributing. Some of you like to use that box method. We get 10x minus 2x squared minus 5 plus 1x. And then I'm going to write down this plus 3x squared and plus 35. We combine like terms and we make sure we write it in standard form. So I'm doing my x squares first. Negative 2x squared plus 3x squared is a 1x squared. My x's combine to be 11x. And then the constants combine to be 30. Now remember, it clearly says write an equation that defines m of x. So if you leave off this m of x equals, you will be marked wrong. So please be very, very careful. Those are the silly points that you never want to lose. Next, it asks us to solve for x when m of x equals 0. So just replace m of x with 0. So right here I see my m of x. I'm going to put a 0 there instead. And this is just solving a quadratic equation by factoring. And it's so nice that the coefficient of the x squared term is 1. Factors of 30 that add to be 11. So I'm going to use the 5 and the 6. I'm going to set each factor equal to 0. If I subtract 5 from both sides, I get that x equals negative 5. If I subtract 6 from both sides, I get that x equals negative 6. So the solutions are negative 5 and negative 6. So my plan is to do number 3 with you. I'll set up 4 and 8. We'll do 14, and we'll do number 1. We're going to do it in that order. So number 3 first. So we've done so many word problems during the year that it should be fairly easy for you to now set up an equation. It's just that since we're in our quadratic unit equation, these word problems will make quadratic equations instead of linear equations. So find two positive numbers whose ratio is 2 to 3 and whose product is 600. Now you might be able to just do this in your head, but let's do it algebraically. Remember, when we have a ratio of numbers, we say that we put an x next to each of these numbers, right? We say that numbers that are in the ratio of 2 to 3 could be lots of numbers. It could be 20 over 30, right? It could be 10 over 15. It could be so many things. So really what's happening is I'm multiplying the top and bottom by some common factor of x. So I'm going to use a 2x and a 3x to represent the two positive numbers. And it says that the product of those numbers is 600. Product means to multiply. So 2x times 3x has to give me 600. So let's multiply this. We get 6x squared equals 600. Now there really are many ways of solving quadratic equations, but the only way we've learned so far is by factoring. And when we do it by factoring, we like it set equal to 0. So let's subtract the 600 from both sides. And remember, we always take out our greatest common factor. Coming over here. And now we have a difference of 2 squares. X squared minus 100 is x plus 10 and x minus 10. I set each factor equal to 0. By the way, this 6 is a factor, but does 6 really equal 0? It doesn't. So that one we usually kind of ignore. We know that 6 is not 0, but maybe the x plus 10 is 0 or the x minus 10 is 0. So if we subtract 10 from both sides, x is a negative 10. If we add 10 to both sides, x is a positive 10. We do get two answers, and I will substitute the x value in place of my let statements. So 2 times 10 is 20, and 3 times 10 is 30. So those are my two positive answers. Now I'm hoping some of you are thinking, well, Mrs. Stans, what about when x is a negative 10? X does equal negative 10. If I put in a negative 10, I get negative 20. And if I put in a negative 10 into the second let's see, I get a negative 30. But it asks me for two positive numbers. So these are two answers that I actually don't use to solve this problem. So I'm not going to use those answers. I'm just going to use the two positive answers. So I said I was going to set up 4 and set up 8 with you. So the product of two consecutive odd, remember, let x equal the first odd, and x plus 2 is the second odd. Remember, odd numbers are 2 away from each other. So the product of those would be x times x plus 2, and that product is 99. This you should now be able to solve. You'll distribute, you'll subtract the 99 from both sides to get it equal to 0. And we should get odd integers. I actually think there's going to be two sets of answers for this. I know I said I was going to set it up with you. I'm going to finish this with you. So we get an x squared plus 2x equals 99. We subtract that 99 from both sides. I love that it's a trinomial with a coefficient of 1 in front of that x squared, because now all I have to do is think of things that multiply to be negative 99, that add to be 2. How about a negative 9 and a positive 11? And we set each factor equal to 0. When I add 9 to both sides, I get x is 9. When I subtract 11 from both sides, I get x is negative 11. So I'm glad I'm finishing this with you, because a lot of people put the wrong answer for such a thing. There are two different values for x. So when I go back to my let statement, when I substitute in my first value of x equals 9, I get that the first odd is 9. And when I plug the 9 in here, 9 plus 2 is 11. So 9 and 11 is one set of consecutive odd integers. Okay, the odd integers are not 9 and negative 11. Those aren't consecutive, right? So I use just my first value of x and plug that into both of my let statements. Then I'm going to use my second value of x and plug that into both let statements. So maybe the first integer is negative 11, and when I plug in a negative 11 into my second let statement, negative 11 plus 2 is negative 9. So the second set of answers is negative 11 and negative 9. There are two sets of answers, and I use both of them here because they didn't specify whether they needed to be positive or negative. So I'm glad I finished that problem with you. Let's go set up number 8. Ratio again. The ratio of the measures of the base and the altitude of a parallelogram is 3 to 4. So remember, a parallelogram looks something like this. An altitude is a height. It's always from the highest point straight down. And the base is this bottom of the parallelogram. And it says, remember, that the ratios of the base and the altitude is 3 to 4. So we'll use a 3x and a 4x for my base and altitude. The area of the parallelogram is 1,200. Remember that area of a parallelogram is, some people say length times width. Usually we say that for a rectangle, not for a parallelogram. For a parallelogram, we like to say base times height. So the area was 1,200. The base, I wrote 3x, and the height, I wrote 4x. So I'll simplify this side to be a 12x squared. We know how to solve quadratic equations by factoring. So you would subtract 1,200 from both sides. I think I'm going to finish this one with you too. I just want you to be set for when I return. There's a GCF, I notice, of 12. And now it's a difference of 2 squares. X plus 10 and x minus 10. I set each factor equal to 0. 12 doesn't equal 0, so I'm only worried about the x plus 10. That might equal 0, and the x minus 10 might equal 0. We subtract 10 from both sides. X equals negative 10. We add 10 to both sides. X equals positive 10. Now in this case, I know I'm actually not going to use one of my answers. Let's go see how come. When I plug in a negative 10, I have 3 times negative 10, which is a negative 30. Can a dimension be negative? It actually can't, right? So lots of times it happens with quadratic equations. You get two answers, and maybe one of the answers we don't use because either they're not asking for it or because it's actually not possible. When you know that you're not going to use something, what we like to do is to put just a line through this and we write reject. Okay, because it is an answer, but we're rejecting that answer for this situation that we're in. I only want to use the positive 10. So I know that my base is going to be 3 times 10, which is 30, is there units here? Centimeters. And my height, or they called it an altitude in this problem, is 4 times 10, which is 40 centimeters. So this is your answer. We rejected the negative because it doesn't make sense when it comes to dimensions of a figure. So there's only 2 more problems I'd planned to do with you. Number 14, and then number 1. So if the length of one side of a square is tripled and the length of an adjacent side is increased by 10, the resulting rectangle has an area that is 6 times the area of the original square. Oh my, this is a tough one. So we had a square that we don't know the dimensions of. So all the sides could just be x, right? And then I changed that square into a rectangle. I'm just going to draw a random rectangle. It's not drawn to scale, that's for sure. It says that the length of one side of a square is tripled. If the length of one side is tripled, it means it got multiplied by 3. So I'll take this side and multiply it by 3. And the adjacent sides, that would be the side next to it, is increased by 10. So we'll say that's an x plus 10. And the resulting rectangle has an area that's 6 times the area of the original square. So what can I write for the area of the original square? Well, area of a square is length times width. So the area of this square, x times x, is x squared, right? So what we can say is that the area of this rectangle is 6 times the area of the original square. 6 times x squared is what the area of this new rectangle will be. Now I'm going to use that rectangle, these dimensions and that area, to write an equation. We know, again, we have to do length times width. So let's do 3x times x plus 10. That area will equal 6x squared. And now I can solve for x. So we'll distribute to get a 3x squared plus 30x equals 6x squared. Now, I mentioned in class that when I'm solving quadratic equations, I prefer my x squared term not to be negative. So when I have to get one side equal to 0, I choose not to subtract the 6x squared. Some people say, well, it's easier. There's only one thing there. But I don't like my squared term to be negative. I think it's easier to factor when my squared term is positive. So I'm going to subtract the 3x squared and subtract the 30x. So 6x squared take away 3x squared is 3x squared. It's positive now. Minus 30x. Don't forget, you always take out your GCF first. Let's take out a 3x, and we're left with x minus 10. And we're done. We're factored. Now we just set each factor equal to 0. So 3x might equal 0, or x minus 10 might equal 0. If 3x equals 0, I have to divide both sides by 3 to get x equal to 0. And on the other side, I have to add 10 to both sides to get x equals 10. So are any of these answers going to be rejected? Well, let's just think for a moment. If I substitute in 0 for my length and my width, what am I going to get? I'm going to get a length of 0 here and a width of 10. What kind of rectangle is 0 by 10? It's actually not a rectangle, right? So hopefully that proves to you that this is getting rejected. We can't have a rectangle if one of its dimensions are 0, right? So we're just going to use the positive 10. 3 times 10 is 30, and 3 plus 10 is 13. And let's see, find the length of the side of the original square. Oh, so let's go back to the original square. Definitely we don't want that 0 because then we don't have a square. So really the length and the width are 10. Find the length of a square. I'm just looking for units. I don't see any. So the length of a side of the original square is 10 units. That's the answer to the question. And let's go see number 1. When the square of a certain number is diminished by 9 times the number, the result is 36. Okay, I don't know what that number is. I'm going to let... Hold on. So I'm letting x equal a number. And now I'm going to go and write the equation. So when the square of a certain number, so they want me to take that number and square it. When the square of a certain number is diminished, to be diminished means something's being subtracted away. It's diminished by 9 times the number. Remember, the number was x, so it's diminished by 9x. The result is 36. We have to factor this, so let's get set equal to 0. And let's find factors of 36, negative 36, that add to be a negative 9. How about negative 12 and 3? Yeah, that works. And we set each factor equal to 0. So x is 12, or x is negative 3. Let's go read. Do they want us to reject any of these? They just say find the number. It doesn't say whether it should be positive or negative, which means there are 2 answers possible. The number could be 12 or negative 3. Okay, so not so bad. I left you problems to do on your own. You're going to do number 2, number 5, number 6. 7 is a graph, so make sure you're using that graphing calculator of yours. Write down a table of values and answer the question that's being asked. You have to do 9. Remember, again, altitude means height. And just a reminder, I see it's about a triangle. Area of a triangle is 1/2 base times height. Number 10, it's a rectangle. 11, it's kind of similar to the problem that we did with the square and changing it into a rectangle. So use that as your guide for number 11. 12, another rectangle. 13, trapezoid. Area of a trapezoid, 1/2 times B1 plus B2 times the height. Remember, a trapezoid looks like this. I'll help you set this one up right now, actually. And that would be its height. So in a trapezoid, the smaller base, so the bases are these 2 sides that are parallel. So the smaller base in my drawing is the top one. The smaller base is 3 more than the height. So I don't know what the height is, so I'll call it x. And the smaller base is 3 more than the height, so I'll call it x plus 3. The larger base, which is my base at the bottom, is 5 less than 3 times the height. So 3 times the height minus 5. 5 less than 3 times the height. And the area of the trapezoid is 45 square centimeters. So if we use the formula for area of a trapezoid, in place of the A for area, we put the 45. And now I have things to put in place of B1 and B2. B1, I'll call the x plus 3. The B2 will be the 3x minus 5. And the height is x. I'll do a little bit of this with you. I'm going to simplify what's in my parentheses to 4x minus 2. So I'm going to first, what am I going to first do? I don't want to distribute first. I want to, remember, these are 3 things being multiplied. I just erased something here. This is a 4x minus 2. Okay, so there are 3 things being multiplied here. Half times these parentheses times this x. So remember, with multiplication, you can multiply in any order that you want. I feel like multiplying this and this together first. So I will get 1/2 x. That's going to be multiplied by 4x minus 2. I think now I want to distribute. I just think maybe it saved me a little bit of work. I would have had to distribute like twice before if I didn't do that first. So 1/2 x times 4x is 2x squared. 1/2 x times a negative 2 is minus 1x. And get it set equal to 0. So 0 equals 2x squared minus x minus 45. You know what, I'll just finish this one with you. This is a trinomial, doesn't have a GCF, and the coefficient here is not a 1. So this is the one where we have to do some trial and error. So the only thing that the 2x squared can be broken into, the only 2 factors are 2x and an x. But this negative 45, I have a few choices. Those are my choices. And which one should I use? I don't know. What if I do negative 5 and 9? I get 18x minus 5x, which does not give me a 1x, so it's not that. What if I switch the order? And I check my outers. I get a negative 10x. I check my inners. Positive 9x, which is a negative x. And that's what this says. So I found it. So now I'm going to set each factor equal to 0. 2x plus 9 equals 0, or x minus 5 equals 0. We'll subtract 9 from both sides and divide by 2. I get x is negative 4.5, and on this other one I get that x is 5. Do either one of these get rejected? Yeah, you're right. We can't have a negative height, so this gets rejected. So I'm going to use that x is 5. It's asking to find the height of the trapezoid. The height is 5 centimeters, and that's the answer to the question. And we did 14 together. 15, you can do it on your own, and that's that. So continue working and finish at home, and I'll answer questions when I see you. See ya. Bye.